So I have this example here where we're going to convert 1 million gallons per day to cubic feet per second, cubic feet per minute, and cubic feet per hour. And I'm going to show the importance of it later on in the video. But let's go ahead and get to it. So a water treatment plant receives 15 MGD from Lake Key. Let's convert this amount to those three units of measurement that I said earlier. So we're going to start with 15 MGD, and we need to convert this cubic feet per second. So you can go through a whole loop of measurements to do this, but I would say if you're in engineering, this is a good one to remember. It'll help you. The conversion factor for 1 MGD equals 1.55 cubic feet per second. Okay. So I want to point out another thing. When people say per, 1 million gallons per day, you write it 1 million gallons per day. So anytime you hear that per, that indicates that whatever the next unit of measurement they say, it goes on the bottom. So cubic feet per second would be cubic feet per second. Okay. So let's go ahead and convert this. So we got 15 MGD. We need to cross out our units. So we know 1 MGD is equal to 1.55 cubic feet per second. So we know our MGD cancels out and we're left with cubic feet per second. So let's do that math. What's 15 times 1.55? That gives us 23.25 cubic feet per second. Okay. So another way to write this would be, as I explained earlier, 23.25 cubic feet per second. Well, let's convert this to cubic feet per minute. So we got seconds on the bottom. We know we got to cancel it out. There's 60 seconds in 1 minute. We see our seconds cancel out. Let's go ahead and do that math right quick. That gives us 1395 cubic feet per minute. Okay. So let's take this number and convert it to cubic feet per hour. So we know we're going to have to get rid of our minutes. How many minutes is in an hour? Well, that's 60 minutes is in 1 hour. Let's do that math. And that comes out to be 83,700 feet cubed per. Okay. So I know a common thing in engineering is making sure your numbers look right, but just doing a little bit of reasoning um with your values. So let's highlight the values we got. We had got 23.25 cubic feet per second. We had got 1395 feet cubed per minute. And we had got 83,700 feet cubed per hour. So if you look at the numbers, you see they're increasing, which makes sense because if we're converting seconds to minutes, you're gonna have more caught in that minute compared to the second. So, and it does the same thing when you're going feet cubed to per minute to feet cubed per hour, it increases because you're catching more in that hour. So logically, our answers make sense. So I want to go over why this is important. So I want to calculate the volume of a basin, and the only given information that you have is that the flow incoming is 15 MGD, and you need a detention time of 5 minutes. So the formula for detention time is like this. It's usually written like theta, and it can be called hydraulic residence time, the volume over Q, right? So what we want to know is what volume of a basin will give us a detention time of 5 minutes under the conditions of there's a flow of 15 million gallons per day. Okay. So this is classic units, making sure your units is right, and you'll see just in a second why. So we're given 5 minutes as the detention time. We don't know our volume. We're solving for a volume. And we know our Q, but if we was to put that in 15 MGD, these units do not cancel out. So this is a no-no. What we need is for those two units to cancel out. So it's the same 15 MGD that we did up here. Which one of these will help us cancel out minutes? This one right here. So let's plug that in. So we got 1395 cubic feet per minute. Now, looking at that, minutes are going to cancel out, and we're left with feet cubed. Now, what is volume? Volume is equal to length times width times height. And if we was to do all these units in feet, we would come out with feet cubed. Therefore, our units are correct, and we can proceed with the calculation. If you guys want another video on how to put this stuff into your calculator, relatively quick, this is a time saver during tests, all that kind of stuff. But for sake of this video, I'll do it the old school manual way so we can see what's going on. So we're gonna multiply 1395 feet cubed per minute times 1395 feet cubed per minute. All right. So that's gonna get rid of our 1395 on the bottom and leave us with volume over here. Those minutes are gonna cancel out. So we gotta do 1395 times 5. That gives us 6,975 feet cubed equals volume. So what if you want to break this down even more? What if you want to know what's the length, what's the width, what's the height? Assuming this is just a rectangular shape, we're not doing a cylinder or anything. What we could do is to break it down into its individual pieces, putting it to the third root. Let's see what we get. We get, I'm gonna say 19.1 feet. So it's 19.1 feet. And this isn't exact. I didn't put in all the units for it. Um, but if you put in all the units for it, all these three numbers will be equal to that. So let's say, like I did, I just cut it off at 19.1. It still should be somewhere around there. It should not be crazy off. So let's see what that is. 667.87. So it went just below it, just a little bit as expected, because I didn't have all the digits in it. But you see, it's right there at it. Numbers I'm comparing, you know. So there, that would be your length, that would be your width, and that's your height if you kept it uniform. Um, and you can go deeper into that, and maybe if you have to tweak the width and the height, um, there's numerous ways to do that, and we could do that in a separate video as well. But I just wanted to go over the basics of some simple conversion that you're definitely going to encounter in engineering curriculum. I believe that's all we got today. Thanks for watching.